This is page 3 of the Chapter 5 test review for Algebra 1A, and we're kicking off with some word problems that have to do with systems of equations. So this first problem is talking about admission to a fair. We're charging $1.50 for children, $4 for adults, and then it talks about how many people are entering the fair and how much money is collected. And I'm making a point about that because when we go to write our equations in Part B, each one of those things is going to have sort of its own setup. But before we get to that, we have to define the variables. And you'll notice that I'm being very specific about, forcing you to do this. I want you in this problem to tell me what the variables are going to be and what they represent. So if I look down here in Part C, it says determine how many adults and how many children are attending the fair. If those are the things that I'm trying to find, those are the things that my variables should represent. So I'm going to use A to represent the number of adults. And notice I'm being very specific about saying the number of adults, not just adults, because if you just say it's adults, we don't know if we're talking about how much they cost or how many there are or how old they are or what it is, okay? And so C represents number of children. And that's what we mean when we say defining the variables. So now when I go to write my system, like I said, I've got kind of two parameters that I have to meet. I have to think about the total number of people and the total amount of money. Those are going to be two separate equations, all right? First off, I have 2,200 people total. So the total of A and C, when I put the number of adults and number of children together, I have a number of people here. And so I'm going to say A plus C equals, 2,200. My second equation is going to deal with the money, okay? And so if children cost $1.50 each, or if we're making $1.50 for children's tickets, and we're making $4 for adult tickets, this equation is going to look like this. 4 times A plus 150 times C. So think about this. This is really saying how much money are we making from adults, and this is how much money are we making from children, okay? And money plus money should equal money. So this is going to equal 5,050. And this guy right here is my system of equations. It's two equations that are representing one situation. Now we're going to solve that system, okay? So first off, I'm just going to rewrite the system here. A plus C equals 2,200. 4A plus 1.5C equals 5,050. And I think the way these are set up, it really looks like elimination would work pretty well. I'm going to just take this top equation and multiply through by -4. That's going to cancel out my A's. Whoops, didn't mean to do that. So I'm going to rewrite that top equation quick. So now I have -4A minus 4C equals -8,800. So now when I add these together, this cancels. 1.5 minus 4, or plus -4, however you want to think about it, is going to be -2.5. And let's see, I might need some help with that last one. 5,050 minus 8,800. Sorry guys, digging for a calculator here. Sorry, you guys probably beat me to that, but -3,750. Okay. Let's divide by the -2.5 on each side. We end up with 1,500. So let's be careful about what that actually means. That means that at this particular fair, there were 1,500 children present out of the 2,200. Okay, so that brings us to the next step. Next step is how do we figure out how many adults there are? technically, mathematically, we're plugging back into this equation, but probably most of you could figure it out without even really using an equation. It's going to look like this. A plus 1,500 equals 2,200. And then I subtract 1,500 from the other side, and I end up with 700 adults. Okay, so I have 1,500 children's tickets and 700 adult tickets that are being sold. Okay, and grand total, that would give me 2,200 people. Okay, and if I really wanted to check it, I could do 4 times 700 plus $1.50 times, what was that other number, 1,500? And it should be that 5,050 number that we were given. Okay, let's look at another word problem. So this one's a little bit different. The structure of this one is different than some of the other ones you've seen. Okay, so probably important to pay attention to. We're planning a wedding. Okay, and important to notice that the way that the reception hall is charging, they charge a rate just to rent the hall, just to rent the room, the physical space, and then they charge per person for catering, for food. Okay. Oh, this should not have a dollar sign in front of it. That's weird. Okay. Elena wants to invite 185 people. Okay, and she knows this will cost $9,400. Jim, trying to be practical, would like to cut costs down to $5,000 and figures out that he could invite 75 people for this amount. So the variables in this situation are a little bit harder to figure out. And this, once again, I think it's best if you look down at part C for what you're actually solving for. Okay. In part C, we need to determine the hall rental fee and the catering charge per person. These two things are going to become my variables. Okay. So I'm going to say H represents the hall rental. And the catering charge per person, we'll just use C. And the two equations in this problem are going to come from Elena's plan and Jim's plan. Okay, so Elena's plan to invite 185 people. If we're inviting 185 people, we're still paying this hall rental fee, right? Plus we're paying 185 times that catering charge. So H plus 185C, and that's going to be $9,400. Using Jim's plan, we're inviting 75 people. So he's still paying this hall rental fee. And he's paying 75 people for catering. And the total cost of that plan is going to be $5,000. So this right here becomes my system. Okay. And then I'm going to solve that. Again, I'm probably going to use elimination. Really, substitution wouldn't be bad here, but elimination clicks pretty quickly. Let me just rewrite. Okay. And I say that because if I just take this, let's say this bottom equation, and make everything negative here before I add things together. So I took everything in the equation and made it negative. When I combine, my h's are going to cancel. All right. 185 plus negative 75 is 110. And 9,400 minus 5,000 is 4,400. Okay. And then when I divide, let's see, I think that's going to be 40, but let's see. 4,400 divided by 110. Yep. So we get a catering charge of $40 a person. It's actually quite reasonable. Okay. So catering charge $40 a person. Now that we know that, we can go back and figure out what that hall rental fee must have been. Okay. So using, let's just say, that top equation, I would go H plus 185 times the 40 is 9,400. Let's figure out this number, the 185 times 40. That comes out to be 7,400. and then subtract, and I believe we end up with a hall rental fee of $2,000. Okay. And that's it on that one. But I do think the equations are a little bit harder to come up with on this one, so that may be one that you want to practice again on your own. Okay. Flipping over here. 19. Okay, so 19 is just another system to solve. 19 is kind of ugly no matter which way you go with it. Substitution, I think your best bet would be to try to get that y by itself, but when you divide by 6, you get some really ugly decimals over here, so I might actually avoid that. Elimination would work okay, but this equation on the bottom is going to have to be rearranged a little bit to match up with that top one. But I think I'm going to take that route. So I'm going to move this 4x to the other side so I can get them to line up with the x and y over here. So I'm going to say plus 4x, plus 4x. Okay. And I think what I will do is just rewrite my whole system over here. So top equation says 2x plus 3y equals 5. Bottom equation is now going to say 4x plus 6y equals 10. Now some of you may be noticing something right now, okay, and that's great if you can make that observation. If you don't see what I'm talking about, just stick with me, you'll see it in just a minute. So we got to get something to cancel out here, and you can pick whether you want to go for x's or y's. I'm going to go for x's, and if I want to turn that 2 into a negative 4 to cancel with this 4, I'm going to multiply the whole top equation by negative 2. And that leaves me with negative 4x. Over here would be negative 6y and negative 10. Okay, so our goal was to get the x's to cancel out, which they certainly do. But you'll notice that it just so happens that my y's cancel and my 10's cancel. Okay, I'm left with 0 equals 0 as my final result. Remember, I don't want you to leave it that way. I want you to tell me what that means. Anytime you get a true statement like that, that means infinitely many solutions. Okay? Really what that means is these two equations are essentially the same equation. You may have noticed when you looked at these two equations that this was really just 2 times all of these numbers, okay? And that means that if I were to graph these two things, they would lie right on top of each other. Okay, let's look at number 20. We're writing another inequality here. And again, I'll remind you that we're starting with this structure, y equals mx plus b. Okay, and then we're just working our way through this. That b value comes from the y-intercept, and that line's kind of thick, so it's hard to tell, but I believe it's supposed to be right there at negative 4. Okay, so I'm putting negative 4 in for b. To get the m value, I want to count up and over to another fairly well-defined point. And all of these kind of look like they're in between grid lines. It's not until I get to this point right here that I feel like that's a pretty solid, integer coordinate point. So I'm going to count from here to here. That's up 1, 2, 3, 4, 5. I want to mark that this way. So to go from here to here, we went up 5, and then we went to the right by 1. Okay, so up 5 and over 1, that's a slope of just 5. So this is 5x minus 4. Okay, gosh, I always space those weird when I write them. Okay, 5x minus 4. It is shaded underneath the line, and I know that's sometimes hard to see when the line is like steeper like that, but if you picture the line kind of tumbling over, if you picture the line kind of collapsing down on itself, this down here would be like the bottom half of the line. This is the direction that it would fall in, okay? And so because it's shaded down here, I'm going to go with a less than. And then because this is a solid line rather than a dotted line, I do also need an equal bar underneath that less than. So that's going to be my final answer. Y is less than or equal to 5x minus 4. All right, 21, we're getting back into some absolute value here. Find all possible solutions. All right, the thing I really want you to try to get through your mind is as soon as you see absolute value, as soon as you see those straight brackets there, there's going to be 2 solutions to deal with. Unless there's no solution, but we'll talk about that, later on. So first thing with this, before you start dealing with that absolute value nonsense, is get rid of anything that's outside of the brackets. So that 2 and that 3, those have got to go first. So I'm going to subtract 3 from each side. And that leaves me with 2 times the absolute value of x minus 5 equals 8. And then I'm going to divide by 2 on each side. And I really, really encourage you to take the time to write what this next step actually looks like. This says, and I'll write it over here, absolute value of x minus 5 is equal to 4. And then think about what this is saying. This is saying that I'm looking for something that is 4 spaces away from 0. That something could be a positive 4 or it could be a negative 4. Both of those things are 4 spaces from 0. So this leads me to x minus 5 could be equal to 4, or x minus 5 could be equal to negative 4. Really what I'm saying is that this thing in here needs to be either a 4 or a negative 4 to get an absolute value of 4. Okay? And I want to figure out what are 2 possibilities for x that could, what's the possibility for x that would make this happen? What's the possibility that would make this happen? You do have to solve these separately. So like on this one, I'm going to add 5 to the other side, and I end up with x equals 9. With this one, I'm going to add 5 to the other side, and I'm going to get x equals 1. Okay, and so it could be 9 or it could be 1. Either one of those would work out correctly in this statement. Okay, if you really wanted to check yourself on this one, remember we did talk about how to do absolute value on your calculator now. Oops, let's hope that holds out. So I could type in, just on my regular calculator screen, 2, and then go find that absolute value command of, what do we get as one of our answers? 9. So 9 minus 5, parentheses, plus 3. And it should come out to be 11, yes? And then I could switch that 9 out for a 1. Okay, so 2 times the absolute value of 1 minus 5 plus 3. And that also works out to be 11. Okay? Okay, carrying on. Show the solution set on a number line. Really, the only part you need to focus on is this right here. And that is just saying that x is everywhere between negative 3 and 5. Literally, it is saying x is greater than negative 3 and smaller than 5. So if this is my negative 3 and this is my 5, and I'm not counting my spaces in between, I probably should, but I'm going to have an open circle on that negative 3. I'm going to have a closed circle on that positive 5, and I'm shading everywhere in between. Okay, so that one was pretty straightforward. When I look at 23, though, 23 is looking for the overlap. Remember, this symbol right here means I'm looking for the overlap between these two things. I'll just squeeze that in there. So I'm going to think about these two things separately, okay? And then I will put the final answer on the number line itself. For this one, I might actually count things out normally. So if this is 0, let's see, this is 1, 2, 3, this would be 4. This would be negative 1. I'm going to need to know all of those things. So this one here, negative 1 is less than or equal to x, less than or equal to 4. This is saying everything between negative 1 and positive 4, all of this. Okay? This one is saying everything greater than 0. So open circle on 0, everything, and this would continue on forever and ever and ever. If this were an or statement, if this were a union rather than an intersection, really I would shade everything from here over, right? Because that would include all of this and all of this, okay? But I'm looking for specifically what's included in both of these pink squiggly lines. And that would only be everything from here to here. I'm going to use the open circle from that one. I'm going to use the closed circle from this one. And then I'm going to shade everything in between. So as far as a final answer goes, if I wanted to write this, this would say something along the lines of 0 is less than x is less than or equal to 4. Technically, it didn't say we had to do that. It just said show it on the number line, but just wanted you to know that you could put these two things together like this. Okay, that's it for page 3. I think we've got one more page to go that gets into a little bit more absolute value stuff. So stay tuned for that.